Morning. Welcome to Current Scum World. In this video, let us study volumetric analysis. In volumetric analysis, double titration, especially Permanganometry, it is most often asked in practical exam. How to write short procedure, how to carry out calculations. Okay, you will see in detail. See the question you will be asked in your exam. In your exam, you will be asked the question: estimate the amount of oxalic acid present in the given solution. Okay, you are provided with approximately decinormal solution of KMnO4 and a standard solution of ferrous ammonium sulfate, or also known as more salt, containing 39.2 gram dissolved in 1 liter. Okay, this is the question you will be asked in the practical exam. Now you will be given three solutions. One is oxalic acid unknown, okay, in small bottle. You will be given three bottles, one small bottle containing oxalic acid, and then two big bottles, one KMnO4, that is 0.1 normal approximately. We need to find the strength accurately by using ferrous ammonium sulfate, a standard, because we know how much dissolved in 1 liter. Ferrous ammonium sulfate is a standard solution. You will be given two bottles, one KMnO4 and another ferrous ammonium sulfate solution. Okay, in the hint they have in the class, the teacher will tell you, make up the unknown in 200 ml SMF flask, standard measuring flask, or 100 ml SMF flask, or 250 ml, whatever may be. We'll see the calculation, how to, in that we'll be using it. Okay, now let us write the in this manner. Let us first write in this manner. Okay, oxalic acid. First write oxalic acid unknown, and then approximate, that is link solution. It is called link, KMnO4 in this case. Okay, and then standard. This is the format. Okay, general format, and then ferrous ammonium sulfate standard, because we know the weight dissolved in 1 liter. And then there are two titration. It is the amount of oxalic acid is estimated by double titration method. In the first titration, okay, this is standard. Let us standardize KMnO4 using standard. This is first titration. And then titration 2, okay, estimation of oxalic acid using standardized KMnO4. Okay, we'll see in detail. Short procedure for titration 1. In titration 1 is the standardization of link KMnO4 using standard ferrous ammonium sulfate solution. Okay, in the burette, KMnO4 is taken, okay, and in pipette, in conical flask, 20 ml of ferrous ammonium sulfate is pipetted out. Okay, and then what is the condition? This reaction takes place in acidic medium. This reaction takes place in acidic medium. Therefore, one test tube, approximately add 20 ml of dilute sulfuric acid to conical flask. And then indicator. What is the indicator used? KMnO4 is itself acting as indicator, self indicator. Okay, you write bracket KMnO4, and what is the color change at the end point? Colorless to pale pink color. The end point is the just appearance of pale pink color. Okay, don't add too much. The equivalent mass of standard. Okay, equivalent mass of standard. We need to write. You will be given mark for this, 392 gram per mole. Let us write the short procedure for titration 2. Titration 2, estimation of oxalic acid using standardized KMnO4. In burette, KMnO4 is taken. Okay. In pipette, oxalic acid, 20 ml of oxalic acid is pipette out into conical flask, and the condition, okay, approximately add one test tube or approximately 20 ml of dilute sulfuric acid to conical flask and heat it to 60 to 70 degree until a first bubble formed. Okay, so this reaction takes place in acidic medium as well as heat, because oxalic acid CC bond is there. In this case, it is broken. It is broken to CO2. The bond is broken, so we need to heat. Okay, this is an to break a bond. It is an endothermic process. So the reaction mixture is heated to 60 to 70 degree. Okay, once it is also an example of autocatalysis. Once it is started, okay, and it will be very fast. It will be autocatalyzed by Mn2 plus ion formed in the reaction. Indicator self, you please write KMnO4, don't write self alone. Okay, and then color change. What is the color change at the end point? Colorless to pale pink color, and equivalent weight of oxalic acid, because estimation of oxalic acid. Link is not required because in calculation we don't need link, only standard and unknown. So equivalent weight of oxalic acid equal to 63 gram per. Okay, now let us see the calculations. According to law of volumetric analysis, N1 V1 equal to N2 V2. Okay, so it is given in the question normal 39.2 gram of ferrous ammonium sulfate is dissolved in 1 liter. So let us use this formula. We have already studied. Please write this formula. Normality formula, weight per liter divided by equivalent weight. So 39.2 gram per liter dissolved in 1 liter. In the question it is given. So you write here, and the equivalent weight of ferrous ammonium sulfate 392 more salt, therefore 0.1 normal. So we have calculated first the normality of ferrous ammonium sulfate. Then from titration 1 we have obtained the concordant titer value 19.5 ml. Okay, so let us write normality of KMnO4 into volume of KMnO4 equal to normality of ferrous ammonium sulfate into volume of ferrous ammonium sulfate. Okay, now we know that normality of ferrous ammonium sulfate here, and volume 20 ml we have pipetted out, and this 19.5. Okay, you just you bring it here, volume, so 19.5 ml, and this is the value normality of. We have now standardized KMnO4. Okay, from titration 2 the concordant titer value is obtained, volume of KMnO4 20.2 ml. Now oxalic acid reacts with the KMnO4, therefore number of equivalents of oxalic acid will be equal to number of equivalents of KMnO4. Therefore let us use this formula, and normality of oxalic acid, let us find out first normality. From normality we can find the weight per liter. Okay, now normality we have calculated here, and volume of KMnO4 20.2 divided by 20 ml we have taken in pipette. So 0.1036 is the normality of oxalic acid. Okay, let us now see the last part of calculation. Normality of oxalic acid. We know we have found the normality. Okay, now weight per liter divided by equivalent weight of oxalic acid. Okay, and then now you write weight per liter. Okay, weight per liter into weight of oxalic acid per liter equal to normality of oxalic acid into equivalent weight of oxalic acid. So normality of oxalic acid we have obtained in the previous slide. You write here and 63. Therefore, weight of oxalic acid per liter we have found out. Now you have made up oxalic acid, unknown oxalic acid in 200 ml SMF flask. Therefore, weight of oxalic acid present in 200 ml. Therefore, in 1000 ml, how many 200 mls are there? 5. Suppose in your teacher says, hint, make up the given solution in 250. Then instead of 200, you put 250. Therefore, in 1000 ml, there are 4 250. Therefore, divided by 4. Suppose your class teacher says, make up the unknown oxalic acid in 100 ml. Then you put 100,000 divided by 10. It will come. So, in this case, weight of oxalic acid in 200 ml. Therefore, it is divided by 5. The answer is this. Okay. So, the result, the amount of oxalic acid present in the whole of the given solution is equal to 1.3057 gram. Okay. Okay. Thank you for watching. For all double titration, the above calculation method is followed. Please understand any one, and we can do any experiment. We can do calculation and etc.